Let's now turn to another domain where these questions are just as urgent: industrial optimization, where even small gains in performance can have major operational and strategic impact. Let's welcome Chiara Vercellino, expert researcher at Links Foundation. Frederic Barbaresco, smart sensing segment leader at Thales. And finally, Etienne Decossin, R&D program manager from EDF. Thank you for being here on stage with us. So my first question is an open question for all of you. Where in your organization do optimization problems become so computationally demanding that exploring quantum or quantum-inspired approaches starts to be necessary?
So actually, in our case, it's a bit different because we don't have, say, our own optimization problem. It's more like companies come to us and they want to investigate quantum. So we see like the limitation of classical optimization under several aspects. One of them, of course, you can imagine it's variables. So as long as you have a lot of variables, then at a certain point, at least a few optimization solvers, classical optimization solvers, starts to struggle. Of course, as also other people said before, if you have, let's say, non-continuous variables, so binary variables, discrete variables, that's also a point where classical optimizer starts to have difficulty to solve the problem. And lastly, I think, yeah, the formulation of the problem. So if you can move at least beyond the polynomial, then you start really having some serious problems to tackle. Yeah.
Frederic?
Thank you. So Thales is leader in aeronautic space and defense, and so we find optimization problem everywhere. We have just started to study optimization with quantum computer because we have a mathematics lab for optimization for more than 20 years, and we have implemented the most advanced optimization algorithm. But we change of scale in our system for aeronautics, space and defense, in aeronautics for air traffic management, because we have to develop now UAV traffic management, drone traffic management. So we change of scale. For the time being, you have 30 million airlines per year. And Thales is a world leader of air traffic management, but now we have to integrate low-level air traffic on drone, and it will change the scale. Second topic is space. So you have all observed that now the market is on constellation, and Thales will join a company with Airbus and Leonardo in Europe to develop new constellation. And the last one is defense. So Thales is working on a very complex air defense system. So we have developed the system for NATO in Europe, and now we are working on a Sky Defender, which is a new dome for air defense with many assets, with sensors and effectors, and we have to be able to allocate in real time resources for this very complex system. So what is pushing Thales for quantum computing is because we are changing scale of our system in aeronautics, space and defense.
So as you may know, EDF is the French national electricity company, and we are celebrating this year our 80th anniversary. And it has always been a major challenge to offer towards our customers electricity at an affordable price. And we are present from the power generation to the customer, and all the electric system is by essence very complex, and so optimization is everywhere. And I should say that the first main problem is to ensure that as electricity cannot be stored or poorly stored, we have to ensure that every time we can generate electricity, decide how we generate electricity and how it is consumed. So we have a lot of constraints, starting for the weather, for the demand, and so on. So it encompasses a huge quantity of optimization problems.
So let me stay with you, Etienne. You've already started to answer that question, but what have these first projects revealed about potential of quantum to improve efficiency or resilience in energy operations?
Yes, of course. It's let's say a long-term effort to define all this optimization algorithm and so on. And it was quite natural to see whether quantum computing can be used for that. We start from heuristics and so on in optimization, but we can also imagine to find different optimization, different results, to get more precise results, to also to get more efficient way of calculating all of these. Some problems require almost real-time decision. Other ones are very complex problem, but for the long term, for instance, scheduling, maintenance of power plants, and so on. And all these fields are candidates to use quantum algorithms.
So let's move from the energy sector back to defense and aerospace with Thales. So Thales has been investigating quantum for mission planning, network optimization. What makes these problems particularly suited for quantum approaches, and what kinds of performance improvements do you see as hardware scales?
Okay, so for the first use case, so is mission planning of constellation of satellites. So we have win 2 contracts with European Space Agency, so the quantum computing for Earth observation and quantum readiness for Earth observation. And we have developed with Pascal an algorithm for planning this constellation, which is a very complex problem. And we have used all the capabilities of your quantum computers because we can position the neutral atom to build the graph that will help us to solve the solution. So it's very accurate programming of the quantum computer of Pascal, and I think it's unique. You are to have this capacity, and we have used all this degree of freedom to optimize the problem. And we have a first return of invest. So we have proved that on 12 satellites, we can increase the number of tasks by 10%, which is not negligible, especially for civil constellation, according to the price of mission for civil application, and obviously for military application. On the second use cases is about communication network. So we have worked with Thales 6 on Pascal to develop some new algorithm for routing. So what we need routing, because we are now entering in what we call collaborative combat, and this collaborative combat will take into account the 3 components. So the surface one, the ground or naval one, the airborne one, and the space one. And we have to build a real-time routing of communication network for having the air and space superiority. And this is the same thing, so it's a problem of optimization. And we have used the particularity of quantum computers from Pascal to optimize at the most accurate level this problem, and to solve the problem for our application.
Thank you very much. Let's move to the utilities focus now with you, Chiara. So Lynx and Pascal built a hybrid quantum, a classical workflow for graph coloring that can be applied, for instance, to design cellular networks and match simulation results on hardware. What did this show about moving hybrid optimization from theory to practice using the real QPU? And how will this work for more complex industrial problems?
Okay, thank you. Very long question.
Yeah.
So yeah, in our case, I think it was very interesting for us, like, to see the whole development of the algorithm, because at first we started with like a very general idea, more focused on the algorithmic side than on the real QPU. So then when we tried to proceed to start using the QPU, we faced other problems, and it was that to me was very nice, because I like to solve problems. So, but it was like it offers us the opportunity to really understand the machine, and so to see where which part of the algorithm was much more suitable for the quantum routine and which side of the algorithm instead was more suitable for a classical approach. And so that's how we developed this hybrid algorithms. It also was very interesting because in the past we had done some separate work, as Pascal has done some work on that, as Links we had done some work on that, and then we had the opportunity to put together our strengths and realize the final algorithm which was much more effective than the two independent ones. So it was also, I think, a nice story of collaboration between the companies. Yeah.
Thank you very much. And one last common question for all of you. Looking ahead at the future, how do you envision quantum optimization evolving from experimentation to integration? What benchmarks, technological milestones will be for you, do you think, the most critical to get there?
I think for EDF, it's the key point on all this class of problem is to scale up. When we start with a classical optimization problem, it is, let's say, thousands of objects in a graph to optimize. When you think about an electrical vehicle fleet, it's millions of objects to optimize in terms of energy exchange and so on. And it was our first steps with Pasqal. A few years ago, we started with them, and all the team worked together in a co-design way to find out how we can use such a quantum computer to implement such programs. So the key point now is clearly to scale up and maybe to find more efficient algorithms to go to industrial scale.
Frederic?
What is important is the benchmark. So Thales is a leader of the French national program, which is called BAC, Application-Oriented Benchmark of Quantum Computers. And very soon we'll make available GitHub with 10 KPI for benchmarking. A few of them for optimization. So we will benchmark quantum computer on optimization. And we are discussing also with Germany, Netherlands, and Poland. Apply for the EuroHPC hybrid computer benchmarking. So it's also important that for optimization problem, we have to upgrade classical computer with AI power computer. So it's important to be able to implement both on QPU on classical computers. This is a challenge also for the scale. We try to promote this benchmark level with the international level with the NATO. Thales is involved in the NATO group in charge of military application of quantum computing, where some optimization problem has been defined.
Thank you, Frederic.
Okay. So I agree with both of them. I agree with needed the scaling up is needed. On the benchmark side, I think beside metrics, providing even better characterizing the problems that can really benefit for approach. I think that would also help find which way it is better to do research to reach advantage or some usefulness before. Yeah, and more or less that. Yeah, thank you. More or less that.
Thank you very much.
Thank you.
Well, thank you for this discussion on industrial optimization, where the need for better performance is already driving serious quantum exploration today. Thank you very much.